I'd like to describe my vision of digital mission engineering. Mission effectiveness analysis has been in use since military operations research was practiced in the 1940s. It has been digital since the earliest computers were installed in the 1950s. It became a required step in the acquisition process since Secretary of Defense Robert McNamara approved the Cost and Operational Effectiveness Analysis, or COIA, in the 1960s. COIA became the Analysis of Alternatives, or AOA, in 2000 with a greater focus on interoperability. This briefing focuses on DoD processes because they are well defined and have a long successful history. Development of non-DoD systems would be well advised to follow a similar process. The key phrase is in an operational environment, which is defined by the defense planning scenarios for a given epoch, specified by the command. This defines the architecture for the future threat environment and the as-is architecture for the future force. The system of systems architecture is dynamic and changes with every clock tick. A scenario should include all the platforms that may interact during the execution of a mission. It is common for acquisition quality simulations to include hundreds to thousands of platforms. Mission engineering should be able to answer for coordinated fire, more bullets, or more radios. Mission and campaign simulation have many virtues over the simple evaluation of system performance. Capturing the impact of the operational environment is of paramount importance. Generating effectiveness results that evaluate how well mission requirements are met allows very different types of architectures to be compared. We can compare apples and oranges and get the most bang for the buck. Measures of effectiveness, or MOEs, should be the primary means of comparing architectures. Measures of performance, or MOPs, that contribute to the MOEs are merely a consequence. A lot of engineers get this wrong, the difference between performance and effectiveness. We'll have a race. I'll give you a Maserati, a great car with outstanding performance and system attributes. 0 to 60 in 4.7 seconds, and a top speed of 185 miles per hour. Of course, that's straight and level at sea level. I'll take a simple everyday horse. 1 horsepower, top speed about 45 miles per hour, but I get to pick the race course. I choose a race to the bottom of the Grand Canyon. Which system will be more effective under these operational conditions? Who will win? The horse wins. So note, the MOEs are quantities of things, not percentages. Effectiveness and performance may look at similar things, but they're measured differently. They're not the same. You can't combine measures of performance to get effectiveness. At a minimum, the evaluation of the effectiveness of a system performing a mission requires the use of a constructive, mission-level, physics-based simulation. If the system of interest is assigned more than one mission type, or certain conditions must exist before the system of interest can be used, a campaign-level simulation is highly recommended. Additional modeling, simulation, and analysis, such as wargaming, engagement analysis, or virtual simulation may also be warranted. The databases for these simulations contain the model of the system of systems architecture. Mission-level requirements are derived from and are traceable to the scenario in the defined vignettes. These simulation databases are valid model-based engineering artifacts and contain the information necessary to produce required DODEF viewpoints. And although the simulations here are combat models, an equivalent mission simulation must be designed for whatever field is being studied, whether it's medical, transportation, education, etc. Now, not all models need to be as extensive, but it should be noted that millions of dollars are invested in these models to improve and extend the representation of the operational environment and creating appropriate scenarios and vignettes. This can't be matched with a simple SysML model. This is an extract from the Joint Capabilities Integration and Development System, or JCIDS, of some key milestones and the analyses that drive them. We'll take a closer look at some of the phases and analyses undertaken during the process. In particular, we'll examine where requirement synthesis takes place. Despite what the documentation says, users do not have requirements or needs. They have wants. Any so-called requirement that is easily given up to save money or maximize another capability wasn't much of a requirement. At this stage of the game, there are no requirements until the capability has been validated and approved. The first analysis in that process is the gap overlap analysis. The second analysis is the analysis of alternatives and the steps leading to milestone B. Then we'll take a closer look at EMD and the analyses that support V&V and system monitoring to examine how we move from one system V to the next. Periodically, a capabilities review and risk assessment process is conducted, or a capability gap is identified in the field. These prompt a concept development study or gap overlap analysis. During this part of the process, we have joint concepts, strategic guidance, and stakeholder wants. One or more could-be architectures are postulated that can close the capability gap. Drawing from the deep well of data, these concepts are evaluated in a capabilities-based assessment to verify the existence of the gaps and whether the gaps can be closed by non-material changes to .mlf or if a new system needs to be acquired. When completed, the Material Development Decision, or MDD, approves the resultant analysis results. The stakeholder wants become validated needs and are documented in the Initial Capabilities Document, or ICD. If a material solution is needed, an AOA is scheduled. There is usually no shortage of candidate architectures going into the AOA. Different stakeholder organizations develop architectures based on differing guidance, organizational bias, SME inputs, etc. These could-be architectures are tested in the capabilities-based assessment focused on the mission. The AOA might use a combination of effectiveness, utility, and performance analyses depending on the complexity of the systems, the missions to be accomplished, and the range of the concepts. The should-be architecture is selected based on the most cost-effective design. The results of the AOA are documented by a final report. The final report records the assumptions, the processes, the architectural details, the results, the interpretation of the results, and the recommendations. At milestone A, the decision makers select the architecture that becomes the to-be architecture. They are not restricted to choosing the should-be architecture. Now, the to-be architecture then forms the basis for the mission requirements document. It also forms the basis for the initial systems requirements document. Now, up to this point, the program office and the system do not exist. This leads us to milestone B, which marks the beginning of the program and the beginning of EMD. I assert the system does not exist before this milestone with the release of the approved systems requirements document. I therefore submit the system model cannot exist before milestone B, at which point system modeling can begin. SysML is about system documentation of requirements, performance, structure, and behavior, not design, whereas mission simulation is about experimental capabilities, effectiveness, and emergent behavior. A system model is static and captures a single point in time. This is not conducive to modeling a mission or a system of systems. A digital twin that generates performance is not sufficient to capture the effectiveness. It cannot capture emergent behavior of a system of systems architecture. It does not address the environment, threats, or temporal changes of the operational environment. The system is derived from the mission. The mission is not part of the system. And while a SysML model is analogous to a blueprint, mission simulation is equivalent to a scale model. So far, we've talked about what happens before the V. Let's look at what happens after. V and V is expected at the end of EMD. The validation should be against the original scenario to show that the system meets the mission requirements. The next step is system monitoring. And while the system was being built, the threat environment was evolving. A check that the system continues to be effective in the years beyond the original epoch is needed. A scenario with a new epoch is chosen to measure the mission effectiveness of the system. This may drive the architecture to a new 2B configuration or block change. And that'll continue until the system can no longer be cost-effectively maintained or upgraded. What would be useful is if the system model could be a digital twin and plugged directly into the simulation. Most engineers really don't understand where requirements come from. Our role as mission analysts has been requirement synthesis, and we really don't get involved in system development. Mission analysis usually tosses the results over the wall and moves on. Mission analysts need to recognize the wider process. System architects interested in where the mission and initial system requirements come from need to become familiar with the mission analysis tools and processes. We need to cross-pollinate our engineers to better understand the end-to-end process. Our clients have the same stovepipe problem. When I was showing interaction diagrams derived from simulations 15 years ago, no one had any interest in using them. System views can be extracted from mission simulations. For those familiar with the Mission Engineering Guidebook, I'm hoping that OUSD R&E acknowledges the guidance provided by the Pre-MDD Handbook and the AOA Handbook. Requirement synthesis relies on scenarios and missions to drive the mission and consequential system requirements. Mission and campaign level simulations have a long history and have evolved to model increased system complexity, including multi-domain architectures. If the only tool you have is a hammer, everything looks like a nail. And just because you can, sort of, model a notional mission in an MBSE tool doesn't mean that you should. The mission campaign model databases are model-based artifacts. Thanks for listening.